So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing fine. Welcome to another physics lecture. So today we'll be starting a new section, that is section number 5, the nuclear physics. And today inshallah in this lecture we'll be covering the section 5.1, the nuclear model of an atom. So the first thing that we discuss is what is an atom. As you know very well from chemistry and basic sciences, an atom is the tiniest particle which makes up all matter. All matter is composed of tiny particles called molecules, which are constantly in motion, and these molecules themselves are made up of groups of atoms. Inside an atom, mostly there's an empty space, nothing else, and at its center it has a small dense area that is full of protons and neutrons, and around that area, around the dense area in the vastness, there are fast moving particles which are known as electrons. Now the electrons outside the nucleus or the center of the atom has a negative charge, whereas the proton inside the nucleus or the center part, they have a positive charge. Atom is the smallest unit of matter that has the characteristic properties of a chemical element. So as such, we say that atom is the building blocks of all matter. This is what an atom is generally depicted. The protons and neutrons are found at the center, and they make up the nucleus, whereas around the nucleus there is a vast empty space and circling fast moving electrons. There was a guy by the name of Ernest Rutherford who performed an experiment in 1909, and they bombarded some radiation onto a thin metal foil. That is also known as the Rutherford's gold foil experiment, and as they wanted to find more about the structure of an atom, the internal structure of an atom. So what they did, a beam of alpha particles were directed at a thin gold foil, and they expected that the alpha particles would travel through the gold foil, and some of them or most of them would change direction by a small amount. They would be deflected by a small amount. What they discovered was majority of the alpha particles, majority of the radiation passed through the gold foil. Some of the alpha particles changed direction but continued through the foil. They were deflected by a very small angle, and few of the alpha particles bounced back right off and came right from where they were generated. The bouncing back could not be explained by the plum pudding model, which was a common atomic model over there, so they had to draft up a new model. This was the first ever evidence of the structure of an atom, the current or the real structure of an atom, the model of the structure that we still use till today. And what they found, this is a depiction of what they found during that experiment. There was a radioactive source and beam of alpha particles, and there was a thin gold foil, and there were detectors surrounding that thin gold foil. So they found most of the alpha particles just went through. Some of them were deflected by a small angle, and few of them bounced right back off. What they found, that majority of them go straight through. This was an evidence. That there is vast amount of empty space inside each atom. Some are deflected through small angles. This happened because the positive alpha particles are repelled by the positive nucleus, which contains most of its mass. So an alpha particle which passed near the nucleus of a gold atom, it was deflected or repelled off slightly. A very small number are deflected straight back because the nuclei of the atoms are very small. So those alpha particles which went straight for the nucleus of an atom of gold, and they just bumped into that head on, they were deflected back at almost the same angle but opposite direction, as nucleus also has a positive charge due to protons, and alpha particles also have a positive charge, so they just bounced right back. The nucleus. Each atom consists of a nucleus and electrons. A nucleus is the core of an atom consisting of protons and neutrons. Together, these particles are known as nucleons, as they are found in the nucleus, and each has almost the same mass. Atoms are mostly empty space. The 99.95% space occupied by an atom is basically empty. Only a 10th billionth part of its the nucleus contains 99.95% of an atom's mass, but only a 10th billionth of its volume. So you can imagine almost 99% of an atom is empty, because all that mass is concentrated in the nucleus or the nucleons. Practically all mass of an atom is the mass of its nucleus. A proton, constituent of every atomic nucleus, is a stable subatomic particle that has a positive charge, that has a single positive electric charge, 1.6 into 10 to power minus 19 coulombs, and a mass of 1.67 into 10 to power minus 27 kilograms. A neutron, which is also present in the center of an atom, has it also consists of very atomic nucleus. It is also a constituent of the atomic nucleus, except in case of hydrogen. It is also a stable subatomic particle that has absolutely no electric charge and has a mass of 1.6 into 10 to minus 27 kilograms. Its mass is same as that of a proton. The only difference is a proton has a positive charge, a neutron does not have a charge, and both of them combinedly make the nucleus of an atom. So proton and neutron are at the center and electrons keep on moving around them. Atoms and ions. An ion is an electrically charged atom or group of atoms formed by the loss or gain of electrons. When an atom loses or gains electron, it becomes an ion, and atoms do that in order to become stable. A stable atom is normally electrically neutral. This means that it would have the same number of protons and electrons. Positive ions are therefore formed when atom loses electrons, so overall it would be having more protons than electrons. For example, this is a sodium atom in its natural form, and as you can see, it is having 11 electrons in its outer shells, and that means there would be 11 protons present in its nucleus. Now it lost one electron and now it has 10 electrons, but the number of protons has remained unchanged, as protons do not take part in forming bonds, only electrons do. Hence now it has an overall charge of +1, because now it is having 11 protons and 10 electrons. So if you do 11 minus 10, you are going to get +1. Negative ions are formed when atoms gain electron so they would be having more number of electrons as compared to the number of protons. For example, this is a sulfur atom that is having 16 total electrons and 16 protons. Now in order to become stable, it has gained 2 electrons from some other element, some other atom, and now it is having 18 electrons and 10 protons. So if you do 16 protons, if you do minus 18 plus 16, you are going to get -2, and that is the charge on this sulfur ion. Proton number and nucleon number. All naturally occurring materials or elements are made up from the elements found in your periodic table, such as hydrogen, helium, sulfur, etc. Atoms of different chemical elements have a different number of protons in their nuclei, and because of that they have different number of electrons in the orbit, as well as in a normal naturally occurring atom, number of protons and electrons are in balance. Chemical elements are characterized and identified by their atomic number, which represents the number of protons in their nuclei, and it also causes them to have unique chemical properties. The proton or atomic number is the number of protons present in the nucleus of an atom. The atom is electrically neutral, hence the atom has the same number of electrons as the number of protons. Means the number of electrons and protons in a naturally occurring element in its neutral state, they are both equal. The nucleon or the mass number is the number of nucleons or the number of protons and neutrons which are present inside the nucleus of an atom. Since the mass of an atom is concentrated, then mass number or the nucleon number is the approximate measure for the mass of an atom. The number of neutrons present in the nucleus, denoted by N, may be deduced by subtracting the proton number from its atomic number, from its nucleon number, that is denoted by A. The formula is given as nucleon number would be equal to the neutron number plus the proton number, which is usually denoted by Z. Nuclide. Nuclides are species of an atom characterized by the number of protons, the number of neutrons, and the energy state of the nucleus. A nuclide is characterized by the mass number and the atomic number. Basically, this is one way of writing the information about a specific atom or element, where you write the chemical symbol like this. X. In place of this X, you would write the chemical symbol of an element. Then on the superscript, in place of this A, you would write the nucleon or the mass number of this certain element, and in the subscript over here on the left hand side, in the subscript, you would write the proton or the atomic number of that element. And this is how we usually represent a nuclide, or we usually represent a chemical element. Isotopes. Isotopes are different atoms of an element that would have the same number of protons or the same atomic number, but they would be having different number of neutrons in their nucleus, hence their mass number would be different. Mass of isotopes of an element would differ as the number of neutrons vary, so there would be a difference in mass number. The number of protons in the nucleus of an atom determines what chemical element it is, and since these atoms contain the same number of protons, they are technically placed at they are given the same place in the periodic table. Chemical reactions only involve electrons. The protons and neutrons take no part in the chemical reactions. Hence, these elements, these isotopes, the atoms of same element having different mass number, they have identical chemical properties. Sometimes they have the same chemical properties, but they usually have different nuclear and physical properties. Every chemical element has one or more isotopes, but they are very often quite rare to find. An atom is first identified and labeled according to the number of protons in the nucleus. This is a hydrogen atom which is there in the periodic table. It has one proton, no neutrons, and one electron. So its mass number is 1. There's a isotope of hydrogen by the name of deuterium, which is having one neutron and one proton in its nucleus and one electron in its shell. Hence its atomic number is all same 1, but its mass number is 2. We have another isotope of hydrogen that is known as tritium, that again have this one electron and one proton but two neutrons in its nucleus. Hence it has a mass number of 3, whereas it has the same atomic number or the proton number as a normal hydrogen atom, which is 1. Example questions. A radioactive nucleus is represented as this is supposed to be let me just write it off. Okay, so here we go. So this radioactive nucleus is represented as U23092. 230 is the mass number and 92 is the atomic number. Which row represents another isotope of the same element? Now the first thing you'll notice is that the first thing you need to know is that all isotopes have the same proton number or the same atomic number. So that means this row, and this row automatically gets cancelled. That means only C can be our answer. But if, let's say for example, there was another 92, then how would you find the correct answer then? Like for example, instead of 91, this was also 92. Then what would you do? What you are going to find another you are going to find the number of neutrons over here as well. You know, this 230 is a combination of the number of protons and number of neutrons. So just subtract 230 and 92 together, and what you are going to find, you are going to get a 138. Now if the original atom is having 138 neutrons, then that means it cannot be an isotope. an isotope will have more number of neutrons or a different number of neutrons than the original atom. So that would also mean that this C, the proton number 92 and the neutron number 139, which is different than the original atom, would be our correct answer. A neutral atom of boron contains 5 electrons and 5 protons. The nucleon number is 11. How many neutrons are there in the atom? Nucleon number or the mass number is a combination of protons and neutrons. So if protons are 5 and the nucleon number is 11, just subtract these two values and that should be your answer. 11 minus 5, that means there should be 6 neutrons. So C would be our answer. Two neutral atoms are atoms of different isotopes of the same element. State one similarity in structure of these two. They both would have the same number of proton. State one difference. They would have the different number of neutrons in their nucleus, or they would have a different mass number. Geiger and Marsden carried out an experiment to investigate the scattering of alpha particles, and here's a diagram of the apparatus, the gold foil experiment. When an alpha particle strikes the fluorescent screen, a flash of light is emitted. On figure 11.1, mark with the letter P where most flashes would occur. As you know, most of an atom is empty space, so most flashes would occur at this dotted line, the point where the alpha beam or the radioactive beam is hitting the screen straight on. Describe what is seen on the other parts of the screen. You would see fewer flashes of light at a smaller angle from this P, or very few or some flashes on same side as the source. That means on the left, because this whole thing is your fluorescent screen. So you would see very few flashes somewhere over here, and you would see some of the flashes over here, like on the right hand side. As we know from the original experiment that some of the alpha particles are deflected by a small angle, very few are completely bounced back, and majority of them just passes right through. State two conclusions about atoms of gold that resulted from this experiment. Nucleus is very small. Most of the mass of an atom is concentrated at the nucleus. A nucleus is very much denser, or you can say majority of an atom is just empty space. And or alternatively you can write something like positive charge is concentrated in the nucleus of an atom, or nucleus is all the positive charge of an atom. So that's it. That's everything you need to know in section 5.1. I hope you have understood everything. Feel free to ask me if you have any questions. I'll see you guys in the next lecture. Take care. Allah Hafiz.